h equals to 90 plus 15t minus 5t squared. Okay, so let me just put it at the side. H is height above ground. Okay, question. What happens when time is equal to 0? This is just to understand what the equation is about. What happens when the time is equal to 0? When time equals to 0, what is the value of h? So fast? I mean, can you already see that it is 90? Just substitute 0, right? What does this mean? When time equals to 0, h equals to 90. The height above the ground is 90, okay? So this tells us that when t equals to 0, height above ground equals to 90 meters. That is what it means. Can? If you look at the diagram, when time equals to 0, it refers to the start of the flight of the ball, right? Because after 10 seconds, the ball will be somewhere. After 20 seconds, the ball will be somewhere else. After 1 second, the ball is also somewhere. But when time equals to 0, it is the start. Do you agree? Time equals 0 is the start, right? Okay, and the height above the ground is 90. So find the height of the building. What do you think is therefore the answer for A? Height of building equals to 90 meters. Because that is the start. Okay? Questions? If not, then part B. Factorize 90 plus 15t minus 5t squared. What is the common factor over here? No, not t. 5. Okay, we can factorize 5 out. We are left with 18. Am I right? Plus 3t minus t squared. Okay, so we factorize this. I require negative t squared. I require 18 and 3t. So here I have no choice, it must be a negative t and a t. And on the other side, 6 and 3. Okay, let's try what happens over here. We get negative 3t. We get 6t. So does this make sense? Okay, so now I will finish up my factorization to give me negative t plus 6 and t plus 3. This is the factorized form. Obviously, you can write it as 5 times of 6 minus t and t plus 3. They are the same thing. So that's part B. And part C. Hence, find the time of flight of the ball. Time of flight of the ball. This is the building. The ball was thrown up and then it went down. Right? So the time of the flight of the ball refers to the time from here all the way up and all the way down. What is the total time taken? How do we find out? Let's go back to our equation. This is our equation for the flight of the ball. When t equals to something, then we get h equals to something, right? For the entire flight of the ball, it started at time equals to 0, okay? The question is, when did it end, right? When the ball reached the bottom over here, is that when we should stop our stopwatch? Yeah, because that tells us the entire time taken, right? Over here, we say that this is 90 meters. Can you tell me what is the value of h over here? What is the value of h over here? 0. Okay, so what do you think happens if I substitute h equals to 0 here? Let's say h equals to 0. That means this equals to 0, right? When this is equal to 0, I get a quadratic equation. Meaning 90 plus 15t minus 5t squared equals 0. So part C, when ball hits floor, H equals to 0. Do we need to write this? No, we don't need to, but I'm writing it so that you know why I let H be equal to 0. So this tells me that 90 plus 15t minus 5t squared equals to 0. And now we have to solve this. We use what we had in part B, which was factorizing. This tells me that 5 times of 6 minus t plus 3 equals to 0. Following so far? And now what can you tell me about the value of t? So I've got something times something times something equals to 0. What should I do to both sides? Divide by 5. Yeah, let's divide by 5. What is 0 divided by 5? Okay, t plus 3 equals to 0. Now I've reduced it to something multiplied by something equals to 0. What can you conclude? If I tell you, for example, a times 5 equals to 0. What can you tell me about a? Oh, yeah, you are right. What if I say 10 times b equals to 0? What can you tell me about b? It must be 0, right? What if I tell you that c times d equals to 0? One of them is 0. Okay, so c equals to 0. Do you agree? It's either c equals to 0 or d equals to 0. Do you agree? It must be one of them, right? Maybe it's both. I don't know. But definitely one of them can be equal to 0. Okay, so we're going to use this idea over here. Now 6 minus t times t plus 3 equals to 0. What can you conclude then? And one of them must be 0, right? So this is what we write. 6 minus t equals to 0. Or t plus 3 equals to 0. Okay? Next, we've got two possibilities over here, just like you said, or it can be c equals 0, it can be d equals 0, right? So I've got two possibilities, 6 minus t equals 0 or t plus 3 equals 0. So for the first possibility, what is t equals to? For this one, what is t equal to? 6 minus t equals 0, so t must be 6. And the other possibility is t equals to negative 3. What does this mean then? T equals to 6, t equals to negative 3. What does t represent? Time. So t equals to 6 when h equals to 0. Time is equal to 6 when h equals to 0. Time equals to negative 3 when h equals to 0. Okay, out of these two, right? We want to find the time of flight. Meaning I want the value of t when h equals to 0, and now I have the answer already. But then I have two answers. Which one is it? I've got two values of t. Which one must it be? Why can't be negative 3? Okay, so we put a reject over here. So we reject this. Here, REJ. To say that, we reject this answer. It doesn't make sense. So my final statement is that part C, time and now for part D, find the value of t when the ball is again at the same level as the top of the building. What does this mean now? When what? When it is 90 meters above the ground. Do you agree? When the ball is again at the same level as the top of the building. So the ball must have bounced back up. Until what height? Until h equals to 90. Okay, so to solve part D, when ball is at same level as top, we've got h equals to 90. So I substitute this back into my equation. 90 equals to 90 plus 15t minus 5t squared. So solve again, we get 5t squared minus 15t equals to 0. This we divide by 5 on both sides. T squared minus 3t equals to 0. Then how do we solve this? One of them is 0. Factorize, yes. What can I factorize out? T. So t minus 3 equals to 0. So what does this imply now? Either t equals to 0 or t minus 3 equals to 0. Right? This is again our a times b equals to 0. So a equals to 0 or b equals to 0. Right? Okay, so I've got two possibilities. T equals 0 or t minus 3 equals 0. Now, let me continue. T minus 3 equals 0 implies that t equals to 3. Okay, now I got two answers again. What do I select? Which one? 3. Why won't you select this? Huh? Time can be equal to 0, right? So why can't t be equal to 0 in this case for part D? Because it's already traveled a distance. What happens when time equals 0? Where was the ball when time equals 0? It was the start, right? So it was at 90, right? This refers to at the beginning. Then it took some time to go up, then came back down. No, this time equals to 3 refers to this path of the ball. When it came until here, this is time equals to 3. Okay? This is over here, time equals to 0. Then it went up, came back down, time equals to 3. Then when it continued to go down, time was equal to 6, is it? Did we say 6? 6. So t equals to 6 seconds. This is what is happening over here. Okay? So how long did the ball take to travel this part? 3 seconds lah. 6 minus 3. Okay? There isn't any distance equal to speed like that. No, there isn't anything like that. It's simply using the formula only, the equation given to us. Okay? And then what does this actually mean? You know, initially we say when h equals to 0, we got t equals to negative 3, right? What does that actually mean? We say time cannot be negative, isn't it? Now, if I were to imagine before, what happened before time equals to 0? The path would have looked like this. So if the ball has started over here, I throw it up, then it will take 3 seconds over here. Then from here, it will continue up to this part, another 3 seconds. Continue down, another 3 seconds. That is what it meant. Okay, that's why over here we've got negative 3 seconds. But it doesn't exist. So, we don't have this in real life also. It's just like that. Can? Any other questions? Is this the only one that you have problems for 2.3? Okay, so let us move on to chapter 5. Okay, so these were the homework questions.